So I guess the case that I was making last time, at least in part, was that one way of conceptualizing the fundamental problem that human beings face is to conceptualize it as an ongoing struggle with complexity. And complexity emerges as a consequence of the sort of finite boundedness of individual consciousness and the incredible excess of the unbounded everywhere else, even including underneath that consciousness, because of course your individual consciousness depends on the function, or is related to the function, of things that are so complex you can't even understand it. So there you are, surrounded by some things that you understand in an ocean of things that you don't understand at all, and including things about yourself. And it's not obvious at all how people solve that problem, because in some sense it's not solvable, the fact that you don't have the cognitive resources or the conceptual resources to understand everything that you need to understand in order to properly orient yourself in the world. Now, obviously, partly the way we deal with that is that we cooperate with other people, and so that radically multiplies our resources, incredibly multiplies our resources. So, and it's something to consider always when, you know, so much of the political dialogue that surrounds us now consists of a critique of cooperative societies and an analysis of their oppressive nature. And of course that's true, because any cooperative system that specifies a certain endpoint and produces a value hierarchy of some sort also simultaneously forces things into that value system and then rank orders people according to the value structure. And so there's an oppressive element to it. But compared to being naked in chaos, generally it's better. Now, it doesn't always have to be, because it can get murderous, but generally speaking, well, look, we're social animals, it doesn't matter. Our evolutionary pathway has already taken us here, and so we're individuals, but we're unbelievably social, and so that's that. So as far as I can tell, we'd have to be completely different creatures not to take advantage of and fall prey to the problems with social being. All right, so I think the way that the problem of complexity has been solved, and this is the best argument I know of for the truth of the Darwinian notion of evolution. Now, I don't think that our models of evolution are complete by any stretch of the imagination. I know they're not, partly because of recent work done on epigenetics, which suggests that you can inherit acquired traits. Right? And when I went to university, when I started going to university in the 1980s, that was heresy, really. Like, no, you cannot inherit acquired traits, but actually you can inherit acquired traits. That's the field of epigenetics studies that. And that's a radical shift in perspective, because we also don't know exactly what that means across any length of time. And when you're thinking about evolutionary lengths of time, you're thinking about 3.5 billion years, because that's the span of time over which life evolved. And so even things that don't have a overwhelmingly marked potency for one generation can be unbelievably powerful across time. And then there's also the issue of sexual selection, because you know, you'll hear Darwinists continually describe the world and the evolutionary world as a place of randomness. And that's not true. And I don't know why they make that statement. The mutations are random or quasi-random, because we don't understand mutations that well yet either. And most mutations are deadly, right? Most mutations are deadly. There's a set of them that are harmful but not deadly. And then there's a tiny, tiny proportion that could, in principle, produce some benefit to the next generation, assuming environmental shift, say, in the direction of the mutation. So, and there's a randomness element to that. We know that. I mean, part of the reason that you mutate, or your cells mutate, your DNA mutates, is because of background levels of radioactivity, and a lot of that's a consequence of solar activity, right? So cosmic rays come zipping through the atmosphere and they nail your DNA and produce minor alterations, and that's a mutation. And if you crank up the background radiation rate, like say around Chernobyl, then the mutation rate rises, and there's definitely a random element to that. And it's necessary for there to be a random element because, as far as I can tell, the only way you can beat a random environment is by producing random changes. Right? So, you know the idea, basically. The environment isn't some static place that's selecting for higher and higher levels of fitness, or not in any, it's certainly not doing that in any static way. And so it's shifting around randomly. And then, you know, you have a structure that's been, your species has a structure that's a consequence of this immense evolutionary journey, and it's moderating itself randomly within certain parameters. The parameters being that most mutations will kill you, like alterations in your fundamental form generally tend to kill you, so they're incremental. And so the mutations are random and they match, hopefully, they match the randomness in the environmental shift, and so you can more or less keep up that way. But then there's additional complicating factors, and they're not trivial, and one of them is whatever epigenetics does. We don't know anything about that yet, but the second one is sexual selection. And sexual selection is no joke. It could be the primary thing, it's certainly one of the primary things that's driven human evolution. And I think you can say that, you think about the environment again. Well, let's think about the environment. So you have a dominance hierarchy, and that's really an old structure. The dominance hierarchy is 300 million years old, because it emerged pretty much whenever there was a nervous system, emergent nervous system, and whenever animals had to occupy the same territory, they automatically organized themselves into something approximating a dominance hierarchy. So it's a very, 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 very old structure. It's older than trees. It's older than flowers. It's old. And as far as real goes from a Darwinian sense, permanent is real. And so when you can say, well, you know, our arboreal ancestors adapted themselves to trees, and so the tree was around long enough to be a feature of the environment. But the dominance hierarchy has been around a lot longer than trees. And you can think of the dominance hierarchy both as an adaptation to the environment, because you'd kind of think about the dominance hierarchy as a cultural construct. But if a cultural construct lasts long enough, then it becomes part of the environment. And so the dominance hierarchy is part of the environment. And what seems to happen, roughly speaking, and this is an oversimplification, but we'll go with it, is that males have a dominance hierarchy, and there's a relatively small number of males that are relatively successful, and those successful males have preferential access to female reproductive capacity, either because the females actively choose the more dominant males, which is very, very common, or because the more dominant males chase all the less dominant males away, so that even if the females don't exercise choice, which they often do, then the only males left around that can serve as reasonable mating partners are the more powerful ones. And so you think you get two really radical determiners of evolution as a consequence of that. One is that each, I'm not talking about female dominance hierarchies at the moment, but I can talk about them, but that's why this is an oversimplification. But what happens is that the males obviously are selected for their ability to move up dominance hierarchies. Obviously, because the ones that are at the top of the dominance hierarchy reproduce preferentially. And so that means the male dominance hierarchy becomes a method of selection. But then allied with that is the female proclivity for choice on whatever dimension the dominance hierarchy happens to be arranged. And so then female sexual selection also becomes a radical, non-random selector of what genetic material is going to move into the next generation. And so I fail to see how any of that can be separated from the emergence of complex nervous systems and mind over the course of evolution, because creatures aren't making random choices. They're not random at all. So we even know such things like, imagine a peacock's tail, you know. It's covered with eyes, which is quite interesting, because eyes, of course, attract attention. And lots of animals have evolved eye-like markings. Like moths, there's moths that when they unfold their wings, they have two big eyes on the back of them. And that's to keep birds from eating them, right? Because the birds don't like being stared at, so they stay away from the moths. But so a peacock's tail is nothing but eyes. And so it's very attractive, and it shimmers. And there's something about it that's beautiful, which is quite interesting too. The females have obviously been selecting the male peacocks for beauty. They have this insane tail. Well, so the evolutionary biologists have thought, well, what possible utility could that tail be? Is it just maybe the females got fixated on tail, so to speak, and you know, you got a Baldwin effect loop going there, and the male peacocks just got bigger and bigger tails, and it's just like an evolutionary dead end. It's, you know, it's a positive feedback system that's gone out of control. But they have done things that, like, look at the symmetry and breadth, say, or the symmetry and size and overall quality of the male peacock's tail as a marker for physical health. So reduced parasite load, for example, and it does turn out that the healthier male peacocks have better tail display. And so what the females seem to be doing is using some marker or some set of markers as a proxy indicator for health. And I think you could say reasonably that female human beings do the same thing to male human beings. And there's some of that vice versa too. Like, we evaluate each other, for example, for symmetry, which is one of the elements of beauty, because healthier people tend to be more symmetrical, and lots of animals use symmetry. Butterflies, if butterflies won't mate with another butterfly if it deviates from symmetry by the tiniest amounts you can imagine. So symmetry is a marker, and there's other markers like shoulder width to waist width is one, and waist width to hip width is another. That's usually what males use that to evaluate females in part. So there's lots of markers of health. But it also looks to me like the data worldwide seems to indicate that women, so imagine that women mate across dominance hierarchies and up, socioeconomically speaking. And on average, across cultures, women go for men who are about 4 to 5 years older. You know, it varies. In the Scandinavian countries, that's shrunk a little bit, but not that much. And in other cultures it's bigger. I would say that depends to some degree on difficulty of establishing economic independence, right? Because in richer countries it's easier to have enough economic independence if you're a male to be a useful participant in the process of having children. But it doesn't matter, cross-culturally it's still across and up, where men mate across and down. They don't care much about socioeconomic status. It doesn't seem to be part of their selection method, generally speaking.